Okay guys, welcome back to my YouTube channel. It's your boy Dr. Shona. So here today we're going to discuss the main problems that an ion develops and how to diagnose each problem and how to fix each problem by yourself. Okay, so basically these are the tools that you're gonna need to repair an iron. This is one of the screws that you're gonna need. For this that we have here, we will need these Torx screwdrivers, which looks like this. These drivers they are like Allen key, but they have a hole at the middle. So you also need a flat screwdriver and a star screwdriver. That's all you need for opening it. So before we go into detail, we will need to I would like to share with you how an iron, basically what is an iron, how does an iron work. Okay, we know that an iron is used to iron clothes, is used to produce heat so that you can straighten your clothes or do whatever. So now, how does an iron work? So I will present to you a diagram showing uh, showing how an iron is connected, how everything works within an iron. Okay guys, I'm through with the diagram. So basically this is how an ion operates. Basically this is the neutral, live and the earth from the main switch. So I don't know why, but I've seen all the ions which I've opened or which I've repaired. I've seen that in these ions they put in these ions they use they put the switch on the neutral side. I don't know why, but this is how basically this is how an ion works. So we have this thermal fuse. This thermal fuse, when you overheat your ion, when the temperature exceeds 240, which is the maximum temperature it should not exceed, your ion, this fuse will be burned out. So this fuse can be burned out through what? Through either high current or secondly high temperature. So most of the time it is affected by high temperature. And okay, after the thermal fuse, that's why I've said TF is thermal fuse. This one is the symbol for a refuse. Then we'll go next to this switch. This is the switch that you operate through this knob here, that you operate through this knob which is over here. So now this switch is not just an ordinary switch, it is a thermal switch. What do we mean when we say thermal fuse? It senses the temperature. When the temperature, suppose we set it to nylon, we set it to okay, okay, let me show you this. Okay, here it is written here to say we have linen, cotton, wool, silk, and synthetic, right? So each of the material here, it has its respective temperature. Okay, so suppose maybe you want to, you're ironing, then you have reached the respective temperature for wool. It will automatically cut out, then it will reset itself when the temperature is getting low again. So this is basically how it operates. And now we have the element. This one is showing the element, which is the ion itself, ne? So, and after the element we have the after the element we have this is the bulb that shows you if it's on or off, if it's drawing current or not. Okay, so another thing is the earth. The earth is this one, which is represented by E, which is connected to the metal chest of the what, to the metal chest of the ion. This is an example of the element that I have here. So you can see that the earth is mounted right to the what, right to the element like this. Okay, so guys, now what are the problems that the ion develops? The main problem that the ion develops, now we're talking about electrically, ne? Okay, so electrically an ion develops the first problem, not heating. The ion cannot heat. Okay, suppose the ion is not heating. These are the most probably the problems. One is either the thermal cutout, the thermal fuse, sorry, is bent or is broken. When the thermal fuse is broken, it cannot allow current or voltage to pass through its, right? So if this fuse is broken, this is the most common problem that I know which develops to many ions. So if this one is broken, it simply means that your iron will not heat, you will not have any heat or any temperature change, any temperature increase on your iron. It will not light even the bulb itself, because it is not receiving any current. There is an open circuit. Okay, so that is problem number one. Problem number two, this switch, it connects and connects respectively to temperature. So over time this switch can be worn out, can be like, they are like the copper wires which are inside, which connects and disconnects respectively depending with the temperature. So these, they get worn out. Sometimes they have a small spark that when it attaches, it sparks. So over time it gets dirty. So sometimes you can just, so okay, let me just say here, it's what, this one can also be broken over time. And the third reason for an ion not heating is the element is broken. The element might be broken. I will show you how to test each component. So now another thing which I have, sorry, but that one is not common. The cable itself can be broken. So I will show you how to test step by step to test an ion. So basically this is the ion, either it's faint or whatever, it works in the same principle. This is the ion. This is how an ion works. So now, if you haven't learned on how to open ion, you can check out on my other videos, which I've made on how to open an ion, which is this one. So right now I will not talk about how to open an ion because already I have recorded a video for that. Okay, so now I will show you how to open an ion. Sorry, I have said I've shown you how to open an ion in the previous video. So now I will show you how to test all the problems, each and every problem. So the first problem that we said one, it can be the cable itself. Number two, it can be the thermal fuse. Then the third one, it can be the switch. And the fourth one, it can be the element itself. The fourth one, the element. Okay, so now let's go. Okay guys, so firstly we have to test number one, which is the cable. So there are two ways. We have to use a multimeter. So as for me today, I will use the cheap one. So there are two methods that you can use to test if what do you call it? There are two methods that you can use to test if the cable is alright or not. So this is how you test. You can use either voltage, you can plug it on power and test here on the live and on the neutral, but this one is not safe, especially for beginners. Maybe you can be electrocuted. So to avoid it, so we are saying that the first one No, we don't use that one. So now we have to use continuity. So I would put my multimeter on continuity here. This is my continuity, 200 200 ohms. Okay, so I'll put it on my. Now I will have to test. This is here. If you can see, this is written live, and you know that live is brown. So we have to put one of our probe here, and then the another one here. Now you can see that we have a reading. We have a reading there, and our reading is 0.5. Okay, so it means our life is okay. Then we go to the neutral. This is how we test the neutral. We go to the blue side. This is the blue side. This is the blue side, the blue, which is the neutral. We can see that we are having a reading there. It's again 0.5 ohms. Now we test our earth, but basically the earth cannot cause an ion not to switch on, not to light, not to switch on. But we are just going to test it for the benefit of the video. Yeah, you can see that it's again 0.5, so it's working fine. So it simply means that our cable is working all right. So we move on. Now we are at the fuse. We move. Now we are at the what? At the thermal fuse. So you can see, if I have shown you earlier, that okay, we have three cables here. Let's ignore this the bulb. Let's ignore the bulb. We have three cables: neutral, earth, and live, like this. And we've tested the cable and we said it's fine. Now you can see that the thermal fuse is connected to the neutral. This is our neutral. Our neutral here is coming through here. We can see that there's this cover here which is protecting something inside. So this is where our thermal fuse is. So we still gonna use what? We're going to use continue to test if this one is working all right. Okay, so I will unscrew this. Oh, okay, this one, it has rust, so just raise this thing up so that you can manage to remove this thermal fuse. Okay, so this is our neutral, and you can see that this is our fuse from the neutral. And now we are here like this. Okay, so here inside here, this is where we have our fuse. So I'll pull this back so that you can see the fuse. It is covered inside here so that it will not earth. If it gets in contact with the metal chase, it will trip the breaker, because the neutral will be in contact with the earth, which will be causing imbalance between the live and the neutral. So now this is it. This is our thermal fuse. So as for me, I have spare. Okay, I have spare thermal fuses. So this is my thermal fuses. Okay, don't mind, these are diodes for microwaves. So I want to show you these are the thermal fuse which I bought. I bought them 10 rand each. They are so cheap. The maximum temperature is 240 degrees Celsius. Okay, so now this is our thermal fuse. So I will show you that if it's working. Now it's our tester, our multimeter is still on ohms, so we have to test it like this. We put one here, then we put another one here. Okay, this shows that you can see that there's continuity here. We have continuity. So this shows that our thermal fuse is working fine. But if your thermal fuse was not working fine, you're going either to replace it, to buy a new one, to replace it, that's what we recommend, or you are just going to bypass this one and make sure that you cover this, because you're going to have a challenge if you don't cover it properly. You need to make sure that this cable does not get in contact with the earth, the neutral. Okay, so you can see that this one is working fine. We have 0.5 ohms. Okay, now we'll proceed. Now we are going to test the switch itself. So how do we test this switch now? We have this cable which is going to the switch after the fuse, and the other one that is now going to the element. I mean this one and here. This is where we test. So we put it here. We put one of our probe here like this. Okay, let me take my alligator clips. So I got my alligator clip. So I will put this alligator clip on one terminal, and I will put it on the new live terminal, on the red terminal like this. So we'll test our switch like this. Yeah, you can see that we have continuity. So we have to rotate it to see if it's working fine. Yes, let's rotate it. Okay guys, then this is how we test it. This one is working fine, is working alright. So you put one probe there, you put the second one there, one here, one here. So one here, one here on the switch. So you can see that it's 16. So if we rotate it, yes, you heard it. Now it's off, on. So it shows you that it's working fine. Now we proceed to test. We proceed to see if the element is working alright. So how do we test the element now? When we're testing the element, you put, these are the terminals of the element. These ones are the terminals of the element. We have one here and two. We just have two terminals for the element. So you put one probe here. Since this one is working fine, we can just put it here. This one is working fine, and we can just put it here like this. You can see that we have how many? We have 33.7, 33.8. Sorry, you cannot see the comma there because I think it's battery. I'm having a challenge with this thing. So you see that there is 33.8. So it shows that it's working fine. 33.6. That's the resistance for this element. So it shows you that the element is working working fine. This one I replaced the challenge was with the switch. So I've already replaced it. So you've seen that it's just a simple things. You don't have too much things. You just have here the fuse, the cable, the fuse, the switch, then the element itself. So I will show you an element which is broken. How does it look? Okay, this one. You cannot see by just visualization to see if it's broken or what. But this one is broken. So I will show you how it tastes when it's broken. Okay. So I told you that when we're testing an element, we put our tester, we put our one here and the other one here like this. So we put one here, then we put the other one here. We don't have anything. If you do whatever that you can try to do, there is a discontinuity here. There is no connection. That's what it means. It's an open circuit. The element is broken. So this one, there's nothing you can do because this one is the price that you can repair for this one is as good as buying a new one. So if the element is broken, just throw it away. But mostly for these other, except for Rob's Rousseau's, this is the one. This one is for Rob's Rousseau's. I've seen that Rob's Rousseau's have a challenge with this one. They are broken. All elements which I've seen, they are broken. Okay. But as for this other one, the platinum, whatever you can call it, I see that it's just the fuse that is broken. Then after the fuse, you press everything, then it will be working fine. As this one. So guys, please, thank you so much. Thank you so much. So I've repaired this one. Let me test it for you so that you see this one working. Sorry for that. I repaired. The time I repaired it, I was not shooting a video. Sorry guys, I'm sorry for that. So now let me check if everything is where it should be. Okay. Everything is at the right position. So now I can test. Okay, so now I can test if it's working fine. Now you can see the light. You see the light? So it shows you that it's hitting. Everything is working fine. Since we have tested the element, we've seen that it's alright. It's working alright. Oh, you see it is switched off automatically. So it shows that the switch is working fine, connecting and disconnecting. So it's perfect. So guys, thank you so much for, please share this video. And I told you that I repair also fridges. So this coming week we're having a lot of videos, coming videos. So if you want to know how does the refrigerator works, how does the micro oven works, how does the satellite dish works, how to install it, how to replace a compressor for a fridge, how to check what is the problem with your fridge, whatever problem that is I'll put everything in the description below, guys. Please, I love you so much. Thank you for watching this video. Thank you for your time. Thank you for taking time to watch my video, to show that. Thank you for your support, guys. It starts with you. Thank you so much. Meet you next time.